and a very good morning. We are from group 2. So my name is Sufi and here's my group members, Christina, Kalisa and Ifai. So next slide. So we choose spinning tops as a real life application of rotational motion. So spinning top, which is gasing, is a real life example of rotational motion. When it is spun, the spinning top rotates around its own axis and can remain stable while spinning. This motion helps us understand basic concepts of rotational motion in physics. As we know, when it is spinning fast, the distribution of its mass around the center creates stability. The faster it spins, the more stubborn it becomes about staying upright. So in this slide, we talk about rotational motion basic. We must first look at the axis of rotation, which is the imaginary line that the top spins around. And then we use the term angular displacement, theta, to measure exactly how much the top has rotated around its fixed axis. This is the same principle you see when a figure skater performs a spin on the ice. Next, I will explain the motion of our spinning top. So, angular velocity describes how fast the spinning top is spinning. So, as you can see at the picture, a faster spin means a higher angular velocity. The initial flick of your fingers provides the starting force that determines the top's height starting angular velocity. So, the formula is omega equal to theta over time. Next, we have angular acceleration. Angular acceleration is a rate of change of angular velocity. As you can see at the picture, when the spinning top is first spun, it has high angular acceleration. Over time, friction and air resistance are the influencing factors that create negative acceleration and stop the rotation.
So now I will explain about centripetal acceleration and force. Centripetal force is the internal tension within the spinning top material and as centripetal force preventing the particle from flying outwards at its peak. So when the object is moving in a circular path, such as spinning top, each particle moves with a constant speed. But though the speed remains constant, the direction of the motion is continuously changing. So because of the continuous change in direction, the particle is accelerating. So acceleration, although the speed is each particle is constant, the direction is changing, which means they are accelerating. This is called centripetal or radial acceleration. So to produce this centripetal acceleration, a force is required. So this force is called centripetal force. So in the case of spinning top, the internal tension within the material of the top provides the centripetal force. This force pulls the particle inwards, preventing them from flying outwards as the object spins. So the formula is AC equal to omega square R, or AC equal to omega square, AC equal to V2 V square over R. So now I will explain about linear angular motion relationship. This slide, so linear velocity and angular velocity are related by V equal to R omega. R is the distance from the axis of rotation, and omega is the angular velocity. So part of the spinning top farther from the center move faster, and linear acceleration is related to angular acceleration.
So, like that. I believe you guys will curious about how the spinning top stay over. Actually, because of the angular momentum keep the top resistant gravity. After that, when they slow down, gravity tries to pull it over. So, because of physics of rotation, will cause the spinning top wobble in the circle instead of falling immediately. This actually, this we try to say about when the spinning top lost the speed, the thing will start moving around to slow it down and immediate instead of falling immediately. So we have a video to show you guys about how the spinning top going along. So in this video, you guys will see the spinning top start moving around because of losing of speed. So we have the evaluation and improvement. Back in the days, we use the wood and metals to make a spinning top. So for these days, we can change the materials to use plastic and plastic. So the first idea we use is the lower center of gravity making the bottom heavy, increase the stability. So when the bottom is heavy, so it will increase the stability of top. For the second idea, we use the metal around it to make the heavy, and also the driver we use the metal ball or the ball bearing to reduce the negative angular acceleration. So that's for we continue to the Q&A section.